Let's take a look at some more problems that deal with direct variation. In this problem it says y is proportional to x and y equals 30 when x is 6. Find the formula for y in terms of x. So this is kind of like that first example that we talked about. The only thing here is that it words a little differently. Y is proportional to x and y. Well, if you remember the little clip of notes we had at the very beginning of that previous video, it says another word for direct variation is proportional. So this means the same thing, right? This right here, this proportional, this also means direct variation. Okay, so we're still using the same basic formula. And it asks us to find the formula for y in terms of x. Again, we're using this formula to create another formula that only has x and y as variables, because we want the formula for y in terms of x. So what we're going to do is take the variables that it gives us, we're going to solve for k, and then we're going to create our new formula. So we have y is 30, and x is 6, okay? So we have 30 equals k times 6. To solve for k, I'm going to divide both sides of this equation by 6, and I'm going to get k equals 5. Now that I know that k equals 5, I'm not being asked to solve for k, I'm being asked to create a formula for y in terms of x. So what I have to do is take my k equals 5 and plug it in to my equation for direct variation, and I'm going to get that y equals 5 times x. Now, this is a formula for y in terms of x where I know my constant value k equals 5. Okay, so that was part A. Part B asks us to find the value of y when x is 5. So if we're trying to find the value of y when x is 5, and we just solved for this formula, we just figured out what this formula is, since this is part A and part B comes right after it, we're still going to be using this equation, this y equals 5x, right? Because they're both under the same set of directions. So find y when x equals 8. All we have to do is plug in 8 for x. So y is going to equal 40. Okay. Now again, we got this formula from the previous example. It's under the same set of directions. We're still using the information that we gathered. Part C is still underneath that same set of directions, so we can still use all the information previously gathered. Okay, part C says to find the value of x when y equals 7. Okay, so we're still going to use that y equals 5x that we found in example A. It says find the value of x when y is 7. We're going to plug in 7 for y, and we're going to find the value of x. So to solve for x, what I'm going to do is divide both sides by 5. And I get x equals 7 over 5. It's okay to get a fraction as an answer. That's a perfectly acceptable answer. 7 over 5 works, right? Because you can't reduce 7 or 5 by any other number. We're going to look at our last example. Alright. It says a stone is dropped from the top of a cliff. The speed of the stone, v in meters per second, varies directly with the time, t seconds, after it was dropped. After 2 seconds, its speed is 19.6 meters per second. Find the formula for v in terms of t. Okay, Now I know that there's a lot going on here. I get that it's a word problem, completely understand, okay? So we're gonna look at how we solve this. First off, I'm gonna get rid of things that don't matter to our problem. A stone was dropped off a cliff. That has really nothing to do with anything. I mean, cool, a stone was dropped, but we don't really need to worry about this sentence. Then we're gonna figure out things that I know, right? The speed of the stone. Okay, the speed of the stone, it says that it was v. This meters per second is just like it's just another term for speed. It's the same as saying like 50 miles an hour. This is v meters per second, right? You don't really need to worry about this so much. Just know that the speed of the stone is going to be v. That's our variable for the speed of the stone. Okay. It says that time is t, and that's in seconds. Okay, so time is t, right? It says after 2 seconds, its speed is 19.6. And it says find the formula for v in terms of t. Okay, now I know that previously we've just worked with y and x, right? The formula for direct variation, y equals k times x. Well, here we have v and t. Now, if we look at it in the order that things are stated, it says v, the speed of the stone, varies directly with t, right? So just like y varies directly with x, v varies directly with t. Okay, it's the same concept. It asks us to find the formula for v in terms of t. So what I need is something other than k to be here. So what I'm going to have to do is take what it gives me, plug in for v and t, and solve for k. Once I know what k is, I can create that formula. So it says after 2 seconds, its speed is 19.6 meters per second. Okay, after 2 seconds. So that means t equals 2, and the speed is 19.6. That means v equals 19.6. Right, so I'm going to go ahead and plug those things in. 19.6 equals k times 2. To solve for k, what I would do is divide 19.6 by 2, right? I would try and get k by itself. 19.6 divided by 2 is going to be, that's terrible, 19.6 divided by 2 is going to be 9.8. So k equals 9.8. Now that I know that, I'm going to rewrite that formula that I had, and I'm going to plug in the value of 9.8 for k. I get v equals 9.8 times t. This is a formula for v in terms of t, which is what we were asked to do. Okay, that's the formula for v in terms of t. Part B to this asks us to find the speed when t is 3. So we're still going to be using this formula because it's under the same set of directions. We now know what the constant value is. K is 9.8. And we're going to solve for v, right? Speed, remember speed is v. And we know that from our previous example, v equals 9.8 times t. Well, it says t equals 3. So v equals 9.8 times 3. Which is going to be 29.4. So after 3 seconds, the speed of the rock is 29.4 meters per second. So that's how you would solve a word problem using the concepts of direct variation.